All right, good morning. Welcome back to trigonometry. We have, I think, another problem that we're working on here. I think this is problem 7C here. Yep, sure is 7C. All right, very good. So this problem, we have tangent squared is equal to 3 halves secant x. Okay, and one of the things we have to figure out is we have two different types of trigonometric function here. We can't do that. So what we're going to have to do is we're going to have to figure out a way to turn tangent to secants or secants into tangents. Now, I have a tangent squared, so that kind of hints to me, it's like there's a Pythagorean identity here. So I'm going to say sine squared plus cosine squared is equal to 1. Let's go ahead and divide everybody by cosine squared and see what happens. So sine squared over cosine squared, we get tangent squared x. Okay, plus cosine over cosine is going to be 1. So is equal to 1 over cosine squared is equal to secant squared. Okay, so I can turn this tangent squared into a secant squared minus 1. So we have tangent squared x is equal to secant squared minus 1. That's what we're going to do. Okay, actually, I'm going to do one thing first. Is I'm going to multiply everything by 2 because a question I frequently ask my face-to-face classes is, do you like the fractions? And no, nobody likes the fractions. And that's the right answer. No, nobody likes the fractions. So let's multiply by 2. So we have 2 tangent squared x is equal to 3 secant x. Now, you have to be careful. I can't turn a secant into a tangent, but I can turn a tangent squared into a secant. See, there's a difference there. So we're going to go ahead and say, well, this is 2, and then tangent is going to be secant squared x minus 1. Don't forget to put parentheses around this because we have to distribute, is equal to 3 secant of x. Okay. Now we have 2 secant squared x minus 2 is equal to secant x. Let's put everything on one side because we have kind of something that looks like a quadratic. So what I'm going to do is I'm going to say, it's probably best to put everything on one side and get it equal to 0. If you're using quadratic formula, you're going to have to get a 0 on the right-hand side. So we have 2 secant squared x. Um, let's see. It looks like minus 3 secant x minus 2 is equal to 0. Great. We could use AC method. 2 times 2 is going to be, well, 2 times negative 2 is negative 4. And if I'm going to go ahead and figure out what it's going to do, it's 4 and a positive 1. That will give me negative 3. So let's go ahead and strip this thing out. So we have 2 secant squared x minus 4 secant x plus 1 secant x minus 2 is equal to 0. Okay, so let's go ahead and we have a first pair, second pair thing that we can go ahead and factor. So we have a 2 secants, okay, and what do we have left? It looks like we just have a secant x, right? Because we had 2 of them here. We moved 1 minus, and then we have 2 here. So we moved a 2 secant x out, so we have 2 left. Plus, and then we have a 1, and then we have a secant x minus 2 equals 0. Think, oh, well, that's kind of nice. So here we go. We can say this is going to be secant x minus 2 times 2 secant x plus 1 is equal to 0. So at that point, we can use zero factor principle. We have secant x minus 2 is equal to 0, or 2 secant x plus 1 is equal to 0. Let's go ahead and solve this. So that's going to be 2 secant x is equal to negative 1. Secant x is equal to negative 1 half. Now, do you remember what the graph of secant looks like? Like, kind of, sort of, but let's go ahead and, we're going to dot this thing as a cosine, and there's a couple of asymptotes here. This is just a really quick graph to kind of see what's going on here. And there's a graph that looks like this, and there's a graph that does this. Okay. Now, where is negative 1 half? Negative 1 half is down here somewhere. This is my negative 1 half. As far as the dotted, the solid line goes for my secant and negative 1 half, these never intersect. This is not an answer that can happen. Okay, so this does not contribute to my solution. This part is no solution. Now, secant is equal to 2, right? Because we have secant x here equals 2. Here's 2 up here. It does connect with the graph in 2 places, but maybe we didn't memorize the unit circle, which is fine. So a fancy way to write secant is 1 over cosine of x is equal to 2. We're going to multiply both sides by cosine x on both sides. So we have 1 is equal to 2 cosine x, or cosine x is equal to 1/2. Now, when I take the inverse cosine of both sides, we have x equals inverse cosine of 1/2. And thinking what cosine looks like is this guy right here. That's over here. That's going to be 60 degrees or pi over 3. Since this problem tells us to report the answer in degrees, then we can leave it as degrees. Okay. The other place we have to worry about is where else is the cosine positive? It's positive in the fourth degree, fourth quadrant. So we're going to say 360 minus 60 degrees. We're going to get a coterminal angle and get 300 degrees. So my answers here, so my solution set is equal to 60 degrees and 300 degrees. Okay, and that would be my solution for this kind of a problem. All right. So the important things to remember is you can't solve these kinds of problems if you have two different trigonometric functions in here. And then look for the squares or look for double angle formula to see if you can convert one into the other so that you'll actually be able to solve it. Okay, so that's how you do these. Don't let the factoring intimidate you, and good luck, everybody. Thank you very much for watching the video, and I will see you in the next one.